It takes a little work to build up the understanding of epsilon delta approach to limits. So let me see if I can show you a cute little web page that will give some intuition. If I Google epsilon delta calculator, I find this epsilon delta game by Desmus. And if I go to that, it will let me look at functions and play around with limits. For example, I can come up here to the second line and type in a function. They have x squared as the default function. I'm going to put in a 1/2 so that I get a more interesting curve. I'm going to make the x value be 4, and in the square root function, the limit had better be 2. And you will see if you look over here at this graph, we have the square root function being graphed, and here is my x value of 4, my y value of 2, and there's some type of epsilon here. Epsilon is 0.5, so we've gone up a half from 2 to 2.5 and down a half to 1.5. The purple band here is the so-called epsilon band. This is my tolerance around 2. And the question is, what tolerance around 4 is required to get in that band? Well, in this case, they've already set up a delta 0.1. This is down here on line 7 on the left, delta 0.1. Well, that certainly works. If delta within 0.1 of 4, we get in this green vertical band and follow it up to the curve, and yes, we're certainly in this purple band, and that means we have a smiley face here just below the origin in our picture. Let me play with this and try to get a little bit better delta. I'm down on line 7 on the left. I'm going to pull delta out, and so I'm going to widen my band, and I can pull it all the way out to 1, and gosh, we're still happy. So let's make this problem a little more interesting. I'm going to move up to line 4. I'm going to put in a different delta. Let's make epsilon. Epsilon is now going to be, let's say, 0.2. If epsilon is 0.2, then moving over to my curve and looking at this horizontal purple stripe, this is the epsilon band where we go up 0.2 from 2 to 2.2 and down to 1.8, and the goal is to demonstrate a limit by choosing x values that will force us into this purple band. So once we've set epsilon equal 0.2 here on the left, let's go down to line 7 where delta is, play around with this. I'm going to pull the little slider to the left and shrink delta. Notice that the red area is shrinking. The red area over here is getting thinner and thinner. My little face is still not happy. We're still not getting into the band. Let's pull a little more, come on. There we go. So if delta is 0.75, then that works for epsilon 0.2. What this means is, in demonstrating that the limit as x goes to 4 gives y value 2, if you tell me that your tolerance in the y-axis is 0.2, this gives me the purple band, then as long as I am within 0.75 of 4, we're good. All right. One more example. Let's pull epsilon down to 0.1. Now my tolerance is smaller. I'm pickier. I say, if you're trying to prove the limit is 2, I want you to get me within 1/10 of 2. There's my thin purple horizontal band around 2, the epsilon band. Here, this vertical stripe is what you might think of the delta band, or delta band. And in this case, if delta is 0.75, that doesn't work. If you're within 0.75 of 4, sometimes you're outside the band. So the purple epsilon band. So let's pull the slider on delta and watch as my little pink box begins to shrink. Sooner or later, I finally get x values that force the y values into the purple band. There we go. About 0.38 will work. So if I give you this function, the square root function, and I say we want to show that the limit at 4 is 2, and I give you epsilon 0.1, then it turns out that delta 0.385 will work. What this means is that if you want to, if I require X values down here and to get Y values up here that fall on this, then I'm allowed to go up and down by 0.385. All right. This is fun to play with, and it gives a nice geometric intuition for the concept of limits for the formal definition using deltas and epsilons. Again, this is at desmos.com. Play around with it a bit.